Okay, today we're going to do trigonometry lesson number 1, trigonometric ratios, on page 203 in your workbook. You're given a right angle triangle, so the first thing you need to do is to make sure it is a right angle triangle. It has that little square there. That square means it's 90 degrees. This is triangle ABC, and we're asked to figure out the trig ratios for it. The first thing we need to do is label the sides. In trigonometry, the side that is opposite the right angle is called hypotenuse, just like for Pythagoras. The other two sides now are dependent on which angle you are interested in. So if we say we are interested in this side, we'll call that angle theta, then that means the side right next to theta is called adjacent. And the side that is opposite angle theta is called opposite. The three trig ratios are sine. So, for example, sine theta. Sine theta is defined as opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. To apply this to this triangle we have here, for our triangle here, my opposite side is AB. So I'll write AB. The hypotenuse is CB or BC. So sine theta equals AB over CB. Cosine, which is adjacent over hypotenuse, my adjacent side is AC divided by my hypotenuse, which is CB. So cosine theta equals AC over CB. Tan theta is opposite over adjacent. My opposite is AB, and my adjacent is AC. Sometimes it is difficult to remember these rules. So there is a mnemonic. It is so, ka, toa. So, S means sine, O is opposite, H is hypotenuse. Ka, C is cosine, A is adjacent over H for hypotenuse, and T, tan, is opposite, which is O, over adjacent. And that will help you remember sine, cosine, and tangent rules. Let's put some numbers in. So for question number 2A, question 2A, we have, well, it's a right angle triangle. We have angle A, two sides of 3 and 4, and a hypotenuse of 5. The table we're asked to find the sine ratio, cosine ratio, and tangent ratio. The first step always is to label your sides. A is the angle I'm interested in it, so this side will be my opposite. Right next door is my adjacent, and across from my 90 degrees is my hypotenuse. Sine A, sine is opposite over hypotenuse, so sine A is 4/5, which is opposite over hypotenuse. Cosine A, so ka, so adjacent over hypotenuse, is 3/5, and tan A, toa, that would be 4/3. Question 2C has this following information. We have a right angle triangle, and the sides are given as follows. Again, we're asked to find sine and cosine and tangent. The step is to label it. The side we are interested in is here. So that becomes, this will be our adjacent. Opposite will be opposite the angle we want. And a hypotenuse is across from the 90 degrees. So sine A, opposite over hypotenuse. Cosine A is adjacent over hypotenuse. Tan A is adjacent over opposite. If you can, you are asked to reduce these fractions. None of these fractions can be reduced, so we're good.